Hello, how are you? Good morning, good afternoon, good evening. Let's get our cup of coffee and start. We continue with yet another comprehensive exercise. We see that we have x squared multiplying to x to the cube plus 5, and those final two terms raised to the 7th multiplied by dx. Everything within the integral. Perfect. How we solve this? We see that we increase or appear to increase. We increase the difficulty. A little bit of the exercises we have been doing from which we have been were left as a task. To this we see that it is more elaborate than it has more terms. But it is more complicated. We can probably, our brain can see it longer to think it's more complicated, but time up there, not exactly a problem, because it looks as long has to be difficult to solve maybe, and there is a possibility that it is easy to solve. This must be clear, and as we commented, universal rule for us, always start with the simplest method to solve a problem every time. Maybe that's the way. Maybe is the right way to go. And we don't complicate our lives trying to solve it with a more elaborate method. Perfect. Not to lose the habit, let's copy again the integral we have here as an exercise. Okay, very well. Let's identify terms. Let's identify values. We see what we have here. We have an x squared 1 variable. Okay, we have in the parenthesis x to the cube, which is another variable, but at a different power. We have 1, 5, which is a constant. We have a power and we have a derivative. We have the dx, or the differential in that case. It could be until now. We could already assume that good goes included with our du. It has yet to be evaluated if it is complete, etc. Very well. Something you can think of is good. And this constant, we can take it out of the integral I had told them whenever possible. And that's where the important thing is. Whenever possible. It should be removed from the integral. Whenever possible, if not possible. No. Okay, in this case, it is not possible to say why, by the simple fact that it is in parentheses, and the power output is raised correct, this parentheses, and that power that is elevated, that elevates everything within the parentheses. That constant is within the parentheses, that constant is here, and that constant alone is not elevated to 7. What is elevated to 7 is all that is in the parentheses. All of this, putting all that here as a little box, is elevated to 7. Then that parenthesis and that power is preventing us from, we can separate these two terms. We would have to see how to solve power to the 7th somehow in order to separate them and try to get that constant out. But high up to there, we are making our lives very complicated by this. Before all that, I always tell the students before moving forward. And to complicate the exercise a little more, let's go for the most basic terms. Let me delete this one for you. Okay, perfect. We continue. We begin that for the chain rule. Let's remember the basics is n plus 1, e in between, n plus a perfect 1. Asks us for a u and asks us for a du. And this du has to be completely correct very well. If complete, we move forward and apply the formula and we solve it, and that's it. And it is not complete. We try to complete it, and remember, which is the only thing we can add are numbers. Nothing more if we cannot complete it. So we are already looking for another method to solve. But so far, our bet is about the simplest method, which is chain rule. Perfect. In that case, we need to choose a u. We could say I'm going to put it in another color. We could say in how many terms we can divide what is within the integral. We can choose one term, and this one is another term. Agree. Why all this? Because x to the cube plus 5 to the 7th is a single term. If it is 2, in x to the cube plus 5 are two terms. Yes. But remember what I told you. As they are in the parenthesis and raised to 7th power are in the parenthesis function, as if it were a single term, because we cannot separate them. Remember? Okay, we have two terms. And what happens to this dx? Well, this one of x is going to be left apart. With the one of u, with the differential, we are going to review whether complete or not. But to begin with, we choose a u. You can choose ox squared or x cubed plus 5. Remember? If you remember in previous episodes, we had seen that whatever we choose as a leave out, the power, we just choose the pure base. We do not take the power into account to choose our u after we derive that u, which is our du, and we check if it is complete or not correct. Perfect. Then we can choose our u as x. An option does not mean that let's do so. But one option is that we may grab x. Good is good, is away x. What will be our du tradio? We already know that it is from x, the derivative we have from x. Yes, we have x perfect. But what happens and what happens to all this that is here? What happens with all this left over? We can't have anything left over. Then how can there be any left over? Because our dx, our du equals dx, and dx is complete, and our u is x squared. We could spare x to the cube plus 5, and we can't spare. It's another rule. We can't have anything left. We can't, nothing left over. Within an integral, it must be used all if we grab something like u everything else, and we had commented on it in previous episodes. Everything else is our du. Everything perfect. in this case, as we have plenty, x to the cube plus 5 raised to the 7th or 7th. In this case, it can't be that way. Let's go back a little bit. We will choose the other way, the other option, which is choose as u, then x to the cube plus 5. Agree? X to the cube plus 5 is a single term because this goes to 7. But when we choose our u, that power is left out. Remember very well, what would be the du? What would be the derivative of our u? We know that the derivative of any number is what derived from any number is 0. The derivative of x, the q. How much is, we would have left 3 times x squared? Yes, very well. In this case, we can review. Let's analyze whether we choose. Well, okay, because it is still the option. There is still a way to go, whether it is not complete or not. About another thing. And we have to use a different method. But until I check, we don't complicate our lives anymore. We need it to be complete. Our differential, which is 3x squared. We know that we can add numbers, but letters? No, then we should have x squared at least. And 0, 3. If we do not have it, we can add it because we can add numbers perfect. We have x squared and we have this x squared very well. We have that 1x squared. What would we be missing? 0, 3. Not this 3 would be missing to complete the differential because this x squared, we already have it. Then in this case, we almost have complete the differential, but we can complete it. Let's add a number that is allowed within the integrals. Let's copy the exercise again in order to explain to them how to complete it. We are going to have this part here. Integral dx squared by x to the cube plus 5 to the 7th dx. Okay, we remember again and we can put here this with our u, and this is part of our du because it is incomplete. It lacks 1, 3. Agree with this dx. It is also du because if you remember the derivative dx to the cube is 3x to the square dx. Do not forget s dx very well. Then what are we missing here to add? We would add 1, 3, which is the one that would be missing. We add here 1, 3, which is the one we are missing. And we can, it is possible, it is allowed, add a number. But here is another rule that we have not detected, and it's a good thing in this exercise. When we add a number that is allowed within an integral, on the outside of the integral, the function must be balanced, or the equation must be balanced if we put 1, 3 inside. Of the integral on the outside, it must be put on the contrary. If it is in the numerator on the outside, it must be put in the denominator at the bottom. If we add 1/3 in the part, externally it would be 1, 3. In this case, we add 1, 3 on the outside, it would be 1/3. Okay, then how would it look like? We would have 1/3 for the integral 3x squared by x cubed plus 5 elevated to 7 by its dx. I always tell the students, you know what you do. Try to close the complete differential. Always try to lock in the complete differential so that they can see that they are not missing anything about our du, how much it should be. Our du is this 3x, the square of x. Okay, I will proceed to lock up our du. This is part of the du and is together with this. X, correct, very well. Why we add 1/3? Because we add 1, 3 inside the integral on the outside. We have to balance and we put 1, 3 in an numerator, which is the upper part, good on the outside of the integral, add 1/3, so as not to affect the equation because that 3 was added by us, it was not there. There we add it very well. Now that we have the complete differential, we proceed. Now we are allowed use the string rule because we already have the du complete, or we have it incomplete, but we can add it, we can complete it, adding 0, 3. Now how would the result look like? We have that. This is the rule formula of the chain very well, which is ours. U that we had taken as you had taken our x to the cube plus 5. Agree. Then we would have x to the cube plus 5. But now it is necessary to use 0, 7, number 7. We have as a power y because it asks us for an nn. The formula agree. Our n would be what our nn it would be. 0, 7, perfect truth. Then we place the n, which would be 0, 7 plus 1 as indicated in the formula between n plus 1, which is 7 plus 1. Okay, how would this look? X to the cube plus 5 raised to 88. Correct? Very well. What is missing? We would have pending. Still add the integration constant. And we would have pending that it is important that we do not forget. We would have to wait to add this 1/3. In the previous episode, we saw that we had to get 1, 2. If you do not remember, go watch the episode. We had to get 1, 2 of the integral. That 2 was going to multiply all our integral solution in this case. As we have 1/3 left out of the integral, that third will multiply. Our solution is part of the solutions. Then how would we stay here? We would have as a result 1/3, which will multiply to x to the cube. Plus 5 raised to 8 out of 8 and more c. Like here, you can add the CEO to the end. Nothing happens. Okay, very well. We perform nothing more. Multiplication of the fractions in this case. And recall part of 1 multiplies the top. And this 3 will multiply to 8. Very good. Now if the solution, how would it look like? 1 per x cubed plus 5 raised to 8 will be the same x to the cube plus 5. Raised to 8 between now. Yes, 3 times 8. How much is 24 more? Now 1/3 for the integration constant. But we have said that 1/3 of c or 2 c or 1000 c does not matter because it is a constant of integration, and so far we do not know the value of the integration constant for the time being. Let's not know how much it is worth. The integration constant is left the same. Then we would have a C, and this would be our solution of the exercise we had here at the top initial, correct? And I hope everything is clear. If you have any questions, please write in comments. If they require any advice, tutoring, or any specific question you may want, contact me at the bottom of the video comes information and we can organize. Take care of yourselves. See you next time. Thank you very much.